In this video, we will learn how to define the trigonometric ratios of angles between 0 and 360 degrees using the coordinate plane. Let's look at the coordinate plane. We have here an acute angle theta between this line and the positive x-axis. We can select any point on this line and call it point P. Let's recall how we define the sine and cosine of acute angles using the coordinate plane. We form the right-angled triangle OPQ and use it to help us to define the sine of angle theta as the y-coordinate of P over the length of OP, and the cosine of angle theta as the x-coordinate of P over the length of OP. How about the tangent of angle theta? It is just the ratio of the side opposite to angle theta to the side adjacent to angle theta in the right-angled triangle OPQ. That is PQ over OQ. This is none other than the y-coordinate of point P over the x-coordinate of point P. These definitions also apply to any angle on the coordinate plane. Let's first look at the case where point P and angle theta lie in the first quadrant. What do you think are the signs of sine, cosine, and tangent of theta in this quadrant? We know that the length of OP is always positive in all quadrants, and the x and y coordinates of point P are always positive in the first quadrant. So all three trigonometric ratios are always positive in this quadrant. What if angle theta is obtuse? Point P will then be in the second quadrant, as we can see here. What can we say about the signs of the trigonometric ratios in this quadrant? Since the x-coordinate of point P is always negative, and the y-coordinate of point P is always positive in this second quadrant, only the sine ratio is always positive in this quadrant, while the cosine and tangent ratios are always negative in this quadrant. If angle theta is now between 180 and 270 degrees, point P will lie in the third quadrant, as we can see here. What can we say about the signs of the trigonometric ratios in this quadrant? Since the x and y coordinates of point P are both always negative in the third quadrant, the sine and cosine ratios are always negative in this quadrant, while only the tangent ratio is always positive in this quadrant. Finally, if angle theta is between 270 and 360 degrees, point P will lie in the fourth quadrant, as we can see here. Let's consider the sine, cosine, and tangent ratios in the fourth quadrant. Would they be positive or negative? You may want to pause the video here to try finding out on your own. We know that the length of OP is always positive in all quadrants. The x-coordinate of point P is always positive, and the y-coordinate of point P is always negative in the fourth quadrant. So, in this quadrant, the sine ratio is always negative, the cosine ratio is always positive, and the tangent ratio is always negative. In short, we have learned how to define the trigonometric ratios of angles up to 360 degrees using the coordinate plane, and how to determine the sign of each trigonometric ratio in each quadrant. All the trigonometric ratios are positive for angles in the first quadrant. Only the sine ratio is positive for angles in the second quadrant. Only the tangent ratio is positive for angles in the third quadrant. And only the cosine ratio is positive for angles in the fourth quadrant.